Hi everyone. So today we are here with a new problem which is combination sum 3. It is a medium type of problem and yeah, I also feel between the easy and medium range. If you solve all the previous problem related to backtracking and all, then it is very easy to you. Now let's see what is the problem statement and then try to understand this problem. So here we have to find all the valid combinations of k numbers that sum up to n, such that we have to follow some conditions. The first condition is we can take numbers from 1 to 9 in order to create the combinations, and the another condition is each number from 1 to 9 is taken once only. We can't repeat any number again and again and again. Okay, and we have to return all the possible valid combinations. So here k is defining the length of the we can say length of the combination, uh, and n is the sum we required, right? Let's suppose we have 1 to 9 as a numbers, and this is the size which is 3 as the size of the combination we have, and 1 to 4 is the number. When we add it we get 7, and there is no such other combination we have, uh, such that if we add it we get the sum as 7, right? That's why there is only one combination. If we go down and you can see, if k is equal to the 3 and n equal to 9, in that case we have three combinations. We can add 1 to 6, we can add 1 3 5, we can add 2 3 4, and that is how we are getting the combinations for sum 9 and k equal to 3. Now we have 4 and n equal to 1. So now we want sum equal to 1, but there is no such combination of 4 from 1 to 9 such that it will gives the sum as 1. So in that case we are not basically getting anything, any combination, and then we return an empty array. If you see this problem, you can see one thing, that what we are doing here. Basically, let's suppose here in this case we have 1 to 9 as a range, and whatever the combinations we get by adding 1 is 1 2 6 and 1 3 5, and whatever the combinations we are getting by adding 2 is 2 3 4. That's it, and that's how we are getting these things. Okay, let's see on the whiteboard how what I am saying is. So let's suppose k is basically the 3, let's suppose, and n is equal to the 4. It means that the length of the combination array is 3 and the sum is 4. So let's suppose if we have 1 2 3 4 5 6 7 8 9. So what we are actually doing here, we basically we basically take one pointer. Let's suppose we are taking one, and then from the rest of element we will take one more. Okay, so how many elements we can add to create combination? 3. So this is 1, this is 2, and then for the rest of the elements, which is from 3 to 9, we can take each and we can check whether it will create some as 4 or not. If it creates, we will store it somewhere. If it not, then we not. And similarly, first we fix our pointer to 2, and then after this we fix our pointer to 3, and after fixing pointer at 3 we can iterate from 4 to 9. Similarly, we can remove this pointer, fix it at 4, and also move the pointer from 5 to 9. And that is how we are basically doing this problem. In order to do this problem using pointers and all, it becomes more complex. We basically use backtracking approach to solve it. So what we do, we basically use a backtracking approach. What is a backtracking approach? Backtracking means whatever these steps we do before, right? We basically have all these. We basically save all these steps what we do before on how much iteration we did for this step, for this step, for this step, and for this step, and we basically try to find the solution in the future. If we find some solution, we will save it. If we not find the solution, we basically backtrack to the previous solution we have and try to find from there. That is the backtracking solution where we backtrack to the previous solution we have and try to find the answer from there. How we get the answer from there? In order to understand this, I will try run one whole input test case for you, but in that I will not take 1 to 9 because that is difficult for me to uh, tell you or dry run you. That's why I will take the range from 1 to 5, okay, so that you can understand it from there. Okay, so let's take example. So let's suppose k is equal to the 3 and n is also equals to the, let's suppose mm, uh, let's suppose 6, right? And let's suppose the range we have is 1, 2, 3, 4, and 5, right? And what we are going to do, we basically try to solve this problem using backtracking. What I do is basically in the first I will take I as 0, okay? It means we are considering the first element of this array, right? If we considering this first element of this array, which is the 0th index of this array, now we require 3, now we take 1, and how much it remains? It remains 2, so it is 2. And now 6 minus 1 is 5, so 5, so this is the sum we want, right? And after this, if we consider 0th element, we have to write the remaining element, which is 2, 3, 4, and 5, okay? And we can also write like, we consider 0, so it basically we also take one more array, empty array, and here we push 1, right? Now this is the new array we have. Now we have to for loop again this array, and we will, what we will do, we will again consider 0th element. So in that case 0, 1, 2, 3. So we will again consider this 0th element, and now k is 2, it becomes 1, and 5 minus 2 is basically 3. So basically this is the sum, left sum we have, and the remaining array is 3, 4, and 5. And now we consider the 0th element, which is 2, so this array is becoming 1 and 2, right? Now in that case you can see that we have one more element remaining we can add. So we can add the 0th element of this array, like you can see 0, 1, and 2. So here it becomes 0, and 3 minus 3 is 0, and the remaining array is 4 and 5. Similarly, we have 1, 2, and 3. Now, whenever at any point of time we will check if our k is 0 and n is equal to 0, it means that we are getting the required combination, which makes the sum as n, which is 1, 2, 3. Now we take this and store it somewhere. We take one big resultant array and we will add 1, 2, and 3, right? Now let's go. So here we take the 0th element, right? Here we take the 0th element. Now what we do, we will take the first element. So if I is equal to the 1, and now the k is again 0, from this you can see k is 1, now it becomes 0, and n is what? So basically we are considering the first element, which is 4, so 3 minus 4 is basically minus 1. In that case, when n is less than 0, it means we are adding a greater value, which is not helpful for us to create the combination. In that case, we don't do anything, we don't consider anything, we return from there, right? And what we do, we consider the second element. So if we consider the second element, so I is equals to the 2, and k is 0, and n is 3, 3 minus 5 is basically 2 minus 2, which is also a very big element, that's why our n is negative, and in that case we also return, we not consider this. Great, very very great. Now in that case, when this part is done, we basically go back from there, right? And here, what we consider 0, so from there we consider 0. Now what we consider 1, so I is equal to the 1, k is what? 2, and n is what? So okay, I'm sorry for this. Basically it is not from there, it is from there, right? Okay, so basically it is from there, and we are taking 0th element, and then we consider I is equal to the 1 element, and then k is equal to the 1, and n is what? So if we take the 1 element, so 5 minus 3 is basically 2. Okay, so it is 2, and the remaining element we have is what? 4 and 5, right? Let me uh, remove rub this so that I have some space. Now, uh, this is 0th and this is the 1 element, and what we consider the first element, which is 1 and 3. So 1 is there and 3 is there. Now let's go, and let's consider the 0th element of this array, and now k is equal to the 0, and then is what? 2 minus 4 is minus 2, so which is negative, so we not consider anything, we return from there. And we consider 1 now, because we are treating all the elements, so we go 1, which is 5. So here the k is 0, and n is equal to the 2 minus 5, which is minus 3, which is negative, so we return from there 2. In that case, we are not getting any combination, right? So we basically now consider I is equals to the 2. So we consider 2, and we do the same process, and you know very well, when we add 4 here, so it becomes 5, right? And after adding 5, there is no small element we can add such that we get the 6. So from this branch we are also not getting any output, and that's how we are iterating 1, 2 and 3. Similarly, we get back. Here we consider what? 0. So here we consider what? I is equal to the 1. In that case, k is equal to the 2, and n is equal to the, if we consider this first element, so what it becomes? 5 minus 2, which is 3. So in our array, what we consider? We consider as 2, and what is the remaining array we have is 3, 4, 5. And the same thing is work for everything, and we get the required combinations from there, and that's how we are getting the solution. At the end we have to return this main array, right? Nested array. Now let's see the code so that you get more things from there, and let's see. So basically what we are going to do is, it is a DFS, or we can say backtracking. So this is the main array which we have to return, and this is the range, like here I am taking the range 1 to 5, but actually in the problem it is specified we can range from 1 to 9. So this is the range of the list, this is the k, and this is the n, this is the empty array, like this one and this 1 2 and this 1 2 3. So this is the empty array we are using in order to store the values. At any point of time, if k is less than 0 or n is less than 0, it means it is not helping us to get the solution, so we return from there. But at any point of time, if k is 0 or and n equal to 0, it means we are getting the required combination. Then we store that path in this resultant array. Okay, and for the rest of the elements, we basically for loop, right? Let's suppose for the 0th element, we consider the 0th element, and we pass the next element. What do you mean by this? Let's suppose this is the array we have, right? So what I do, I will consider this one, and for the next iteration I pass from 2 to 3, 4, 5. So similarly, the next array is the element which we consider is removed from this array and pass this. K is minus 1, and whatever the array, whatever the element we consider, that is removed from this sum, and it is also stored in the path. And that's how we are doing this, and at the end we basically get the solution in this array that we can easily return. I hope you got the whole thing, how it actually works, how we are getting the solution. If not, you can basically comment out, and I will help you, surely help you. And thank you so much. Bye.